First law of thermodynamics. An intrepid scientist placed an unknown salt in a small amount of water. After the salt had dissolved, the temperature dropped several degrees. We want to know what the sign of enthalpy change for this reaction is. Well, we know that endothermic reactions, the sign of enthalpy change is always going to be positive, and exothermic reactions, it's always going to be negative. Since we know that the temperature dropped, we know that heat was actually released, indicating it's an exothermic reaction. And since we know it's an exothermic reaction, we know that the change of enthalpy is negative. For question 4b, assuming that heat capacity of the solution is the same as pure water, how would the scientists calculate the molar enthalpy change? Well, we use the equation Q equals mass times heat capacity times change of temperature. Often they'll give you mass in milliliters, or I guess in volume. In the case for water, we know that the density of water is 1 grams per milliliter, so we can just make a conversion 1 milliliter into 1 gram. And since this heat capacity can be assumed the same as pure water, we'll just use 4.181 joules per gram times Celsius, which can be found in the standard heat capacity table. And they'll give you the change of temperature. And what you want to do is just multiply all that, and you'll be left with joules. But since they're asking you for molar enthalpy change, you're gonna need to divide this by moles of the salt. And you do this by, well, in an actual problem, it'll probably give you grams of this salt. And what you want to do is times it by molar mass, and you'll get the moles, and that's how you can just divide it. And your units will end up being joules per mole. Next question. Propose an explanation for the decrease in temperature. Well, the decrease in temperature can be shown when salt is added. It decreases the freezing point. So let's say you had a block of ice and you added salt to it. It'll start melting. And in order for something to melt, it's going to need energy. And that energy of the ice melting comes from the salt water inside of the solution. Thus, when the thermometer is checking for temperature, it's seeing that it's finding the heat of the salt water, which is decreasing in temperature because it's giving energy to the melting ice. And that is why we pour salt on frozen roads.